So now let's come to the most popular part of the lecture. It's about what are Kelvin waves. Okay, no, these are not Kelvin waves. So what's shown here are geostrophic eddies in the open ocean. Okay? It's a good starting point to understand Kelvin waves. So let's have a look at these geostrophic eddies. So geostrophic eddies are features whereby the currents, the geostrophic currents, run around centers of either high pressure, called H, or low pressure, called L. Okay? And the direction of these currents differs from the northern to the southern hemisphere. Okay? These are not Kelvin waves, but imagine what happens if these features interact with the coastline or with the equator. Okay? If you produce a feature like this near a coastline, let's have a look how it looks like here. Now on the next slide. Okay. Here are examples of snapshot photos of sea level anomalies of either high pressure or low pressure, either along the coast, in the northern hemisphere, in the southern hemisphere, or along the equator. The left image is a top view. You look from above, shows you high pressure features on the right side, low pressure. So how do you create these features? Well, you need a wind and Ekman transport, and you blow, you force water against the coastline, and you can create these features. Okay. So now, how do they propagate? I try to illustrate. Okay, let's have a look at one high pressure system. Okay, let's have a look at the structure here, which is in the top left corner. Okay, you are on the western side of the North Atlantic, and the wind has created a high pressure cell. This is half an eddy. Okay, water is elevated along the coastline. So you have something like half a meter or 1 meter elevated sea level. So what's shown here in this instance are the geostrophic currents that develop as part of we call it the geostrophic adjustment. And you learned this, they run along the pressure contours, okay, and they run from north to south. And what they do is they interact with the coastline. What they actually do is they increase the sea level here on one side, okay, in the south, and they reduce the sea level in the north. If you think about it, you actually can work out that you get a system that moves along the coast with the coast on the right in the northern hemisphere. So this entire structure would move towards the equator, whereas the one on the other side would move towards the pole. Okay? In the southern hemisphere, you get a reverse propagation direction. These features would propagate along the coast, having the coast on their left. What happens near the equator? Look at this. Near the equator, you get a weird type of system where indeed you can produce a high pressure anomaly along the equator, but the geostrophic currents are sort of a little bit weird. Yeah, at the equator directly, there's no Coriolis force, but within 100 kilometers or so, this already kicks in the geostrophic. So you have currents that go to the east, both north and south of the equator, and these currents, they produce a convergence on the eastern part of this feature and the divergence on the western part, and as a consequence, this wave can only propagate to the right, because the water continuously, the high pressure develops in the east and is reduced to normal on the western side. Okay? And if you now look at low pressure systems, they actually behave exactly the same way. Okay, also the low pressure system can only travel eastward along the equator. Okay? Can only travel with the coast on their right in the northern hemisphere, on the left in the southern hemisphere. And the reason of that is that the divergence that you can create creates a low pressure in the eastern bit here along the equator, for example, and the convergence just brings the sea level back to normal on the western side. So these are Kelvin waves. They can be created, but they propagate along the coast. Okay, so think about that. Print out this slide and think about it and explain it to your neighbor or your grandma. These are important waves in the ocean. Okay, Kelvin waves.